Hi everyone! In this video, we're going to apply everything that we have learned about a polynomial function and its graph and try to sketch the graph of the given function. If you get lost throughout any of the steps that we're going to perform, please re-watch the previous videos where we learn in details all those steps. We're going to start by determining the end behavior of the graph of this function. To determine the end behavior, we need to know the highest power of x in this function, or in other words, the degree of this polynomial. And we need to know the sign of the leading coefficient. In this case, if we expand this expression by performing the operations, 1/3 will still be the coefficient, and the highest power of x will be obtained by multiplying x squared by x cubed. In other words, the leading term of this function is 1/3 x to the 5th power. So the highest power of x in this function is 5, which is an odd number. The leading coefficient is positive. So the end behavior of the given function is going to be the same as the end behavior of the function x cubed, because it also has the odd degree and the positive leading coefficient. This is the shape that the graph of the cube function takes. And from this we can conclude that the right end of the graph of the given function goes up and the left end goes down. And on this xy plane, I can already sketch these directions. The right end will go up and the left end will go down. It doesn't mean that my graph will be positioned exactly here or here. Again, this is just the direction. But I will use these directions as the guideline for the rest of the graph. In the next step, step 2, we're going to find the y-intercept. Remember, the y-intercept is the place where the graph crosses the y-axis. And since any point on the y-axis has x-coordinate 0, we find the y-intercept by plugging in 0 into the function. In other words, I'll need to find f of 0. I plugged 0 into the function and found that the y-intercept is 3. In other words, it's the point 0, 3. So the graph will cross the y-axis at this point here. In the next step, step 3, we'll need to determine the x-intercepts and their types. X-intercepts are points where the graph crosses the x-axis. Any point on the x-axis has the y-coordinate 0, and that's how we find the x-intercepts, by letting y equal 0, in other words, by setting function equals 0, and solving the resulting equation. Since this polynomial equation is already in factored form, to find solutions, we simply set each factor equal to 0, and then solve each little equation. I had to square root both sides for the first one and cube root both sides for the second one to get rid of powers. And then from each, I was able to determine the x value. So x equals 3 and x equals -1. These are the x-intercepts. But we also need to know their types. Remember how we learned that there are 3 types of x-intercepts: touch point, the cross point, and the point of inflection. And the type of the x-intercept will depend on the multiplicity of each 0. Multiplicity of x equals 3 is 2. Basically, the solution x equals 3 is repeated twice because of the second power. And then when multiplicity is even, the x-intercept is the touch point. So at x equals 3, the graph is not going to cross the x-axis, but it's simply going to touch it. And there are usually 2 ways for the graph to touch the x-axis, either from above or from below. What's going to be our case? Well, since we know that the right end goes up, then the graph has to touch the x-axis of 3 from the top. How about the second x-intercept? Its multiplicity is 3, so it's an odd multiplicity. An odd multiplicity that's 3 and up corresponds to the point of inflection. So at x equals 1, we have to sketch a point of inflection. That's the one that has half of the frown and half of the smile. Half of the frown here, and then half of the smile here. And that's how we can sketch this bending graph. So it looks like I positioned this end point too far, but remember it was just a sketch. So I need to move it closer and connect with this portion of the graph. Well, we're getting there. Almost done. These are the main 3 steps where we determine the key features of the graph. In step 4, we're going to try to draw the preliminary sketch of the graph. We already have this portion. Now we need to connect that with the y-intercept. So obviously the line goes up. And I see that I need to connect these two pieces. So it means that somewhere there should be a turning point for this graph. But I don't know where it is, so for now I'll just make a rough sketch. And in the last step, I'll find additional points for more accuracy. Obviously, this is the portion of the graph that I'm not certain about. I need to get some idea of where this turning point happens. So this tells me that I need to find a few more additional points at x values around 1 and 2. So I'll try to find 3 additional points at x equals 1, x equals 1.5, and x equals 2. To find the corresponding y values or function values, I simply have to plug the chosen x values into the function. Okay, so these are the 3 points that I computed for x equals 1, 1.5, and 2. I found the corresponding y values. And now I'm going to plot those points on the graph. This is where the 3 points are located. That tells me that the turning point of the graph happens further up. So I'm going to try to connect them with the rest of the graph. Okay, so that's how the sketch of my graph looks like. It doesn't look perfect, but the sketch is very close to the graph of the given function. What's important is that I have all the correct intercepts, the y-intercept and x-intercepts, including their types, the touch point, the point of inflection, the endpoints go in the right direction, and the additional points that I found gave me the pretty good idea where the turning point happens, compared to the graph that I obtained using a technology.